Hey everybody, this is your first video of math intervention for this year, and we're starting with the conceptualization of fractions because understanding fractions, knowing how to work with fractions, and being able to see fractions in your mind is absolutely necessary in order to do well in middle and high school math and later on. But before we get to that, I want you to look at what I have written here and really take this to heart, because this is going to be an expectation for the entire school year. And if you follow me and do as I'm asking you to do, I guarantee that your math skills will increase simply because of the organization that you'll be forced to do because you're using this sort of grid paper. So before beginning, as you write numbers in your graph paper notebooks, it is necessary for you to write your numbers the correct way. If you do, your understanding of fractions will increase significantly. If you don't, you'll more than likely make mistakes that will impede your learning. So on the left-hand side, I have modeled for you how the numbers should look in your graphing notebook. And on the right-hand side, I've shown you the incorrect way of doing it, even though I've given you correct answers to show for that. So on the left-hand side, you have one digit per box. So in the question, 342 plus 229, I have that modeled, as you can see here. And then I have model 342 minus 229 here subtracted. And in the adding part, you can see 2 plus 9 is 11, carry my 1. I have a plus 1 in the tens place column. 1 plus 4 plus 2 is 7, 3 plus 2 is 5, making the answer 571. In the subtraction question, I cannot take 9 from 2, so then I borrow and regroup. This 4 becomes a 3, and then that 2 becomes a 12. Only then is it okay to write two digits in a box, and the reason for that is so that you can see clearly how you borrowed and regrouped. And then it becomes 12 minus 9 is 3, 3 minus 2 is 1, 3 minus 2 is 1, giving you the answer of 113. I also use different colors to model when borrowing and regrouping occurs, especially with subtraction. I'm not going to ask you to do that, but if it does help you to see the patterns, by all means, you're more than welcome to do that. And over here on this side, you can see, even though I've given you the correct answers, it just is sloppy. And especially when you do subtracting or in multiplication, especially, when you write your numbers bunched up like this, it is very easy to make a mistake when you're carrying numbers or you're trying to multiply by moving over. Let's say you had 32 times 17, for example. If you were trying to write this here, I've modeled this the correct way, but even though it's written in the correct way, these numbers show by you the place value of how your answer comes in together. So, for example, when you're multiplying 32 times 17, the first time 32 times 7, you're multiplying it by 32 times 7, which becomes 224. But when I move it over here, and some teachers tell you to draw an arrow, some tell you to draw a 0, some people actually tell you to draw an X. What you're actually doing here is you're multiplying 32 times 10, not 32 times 1. But we'll get to more multiplication later. The point of this is to show you how the numbers are supposed to be modeled. Fractions are a way to express part of a whole. Decimals also can do this, but not perfectly with certain numbers. Fractions can always be perfect. Models can be used to describe fractions. Here I have shown you, these are fraction tiles, and in this illustration you've got 1 whole, 1/2, a third, a fourth, a fifth, a sixth, 1/8, 1/10, and 1/12. There are other models that can be created. This just happens to be the one that I've used to show you how the fractions can be modeled. You can also use circles. I'm using tiles because they can transfer to your graphing notebook more easily than using circles. So let's look at the fraction question, 2/3 plus 1/4. people who do not have a good, solid understanding of fractions would say that the answer to this question is 3/7 because they just add 2 plus 1, and they add 3 plus 4, and they get 3/7. But 3/7 is less than 2/3. And when you're adding two fractions together, you're going to end up with something that's larger, not smaller than what you started with. That's been modeled in this illustration here. Then down here, I did it in a line. I did 1/3 plus 1/3 plus 1/4. And someone who really doesn't have a fraction understanding would do 1 plus 1 plus 1, which is 3. And then 3 plus 3 plus 4, which is 10 and 3/10. This is what 3/10 actually looks like. 3/10 is less than 1/3. So this is a reason why being able to see fractions in your mind is why it is so important in order to be able to understand them. This is how we would model 2/3 plus 1/4 correctly. So we have a third here, a third here, and a fourth here. And teachers have taught you that you have, in order to add fractions with unlike denominators, you have to do what's called the least common denominator, or we call that the least common multiple. And here I've shown this by skip counting. And what I've done is I have skip counted until I find a number that both 3 and 4 share. And in this instance, it is 12. So I have to then figure out if a denominator is 12, what would the numerator be if the original fraction is 2/3? So the way that I do this is I ask myself, how many times does 3 go into 12? Well, the answer is 4. I then use that number and multiply 2 times 4, and I get 8. This is saying that 2/3 is equivalent to 8/12. I repeat the same procedure over here with 1/4. 4 goes into 12 3 times, and 1 times 3 equals 3. I then can add these fractions because now my denominators are the same. 8 plus 3 is 11, and I never, ever, ever add the denominators together because then if I were to do that, I'm actually making the fractions into even smaller pieces, which doesn't make any sense. That gives me the answer of 11/12. To do fractions quickly without the benefit of fraction tiles, your graphing notebook can become one. So in this question, I have 2/5 plus 1/3, and I ask myself, what is the smallest multiple of 5 and 3? By skip counting, I get to 15. And what I do in my graphing notebook is now I'm going to draw a rectangle that is 15 squares long. And I'm going to do that 2 separate times. My 2/5 is here and my 1/3 is here. I then, right over here on the side, I say how many times does 5 go into 15? That's 3. I then multiply 2 times 3, which is 6. So this is saying that 2/5 and 6/15 are worth the same amount. I then take some sort of different color and I shade 6 of these little squares here. My fraction shown here is 6/15. I repeat the same procedure below with 1/3. 3 goes into 15 5 times. 1 times 5 is 5. I then shade 5 of these little squares here. I then can add 6/15 plus 5/15, and I get 11/15 as my final sum. Let's try a question without a model. In this one, I've got 1/7 plus 2/3. I ask myself first, what is the smallest multiple between 7 and 3, and I'm going to skip count to get this. There's a different way to do this, but right now we're just doing skip counting so that you can get the idea of what to do when you're trying to figure out when you're trying to figure out multiples to convert fractions to make them equivalent with each other. So in this instance, I skip counted 7, then 14, then 21. And below I went 3, 6, 9, 12, 15, 18, 21. 21 is the smallest one that they share. Notice how I'll write this here. I wrote 1/7 plus 2/3 in a straight line, neat going up and down. I then draw arrows to convert these with the least common denominator of 21. And I ask myself, 7 goes into 21 3 times. 1 times 3 is 3. So that's saying that 1/7 is equivalent to 3 21s. I then say 3 and a 21 is 7 times, and 2 times 7 is 14. Now that both denominators are equivalent, I can add the numerators together. 3 plus 14 is 17, and that gives me the sum of 17 over 21. So that is saying that 1/7 plus 2/3 is equivalent to 17 over 21. The 21 again came from that being the smallest multiple that the two denominators shared. Let's try these three questions. 3/4 plus 1/5, 4/9 plus 1/4, and 3/8 plus 3/4. The least common multiple of 4 and 5 is 20. I then do 5 and a 20 is 4 times, 1 times 4 is 4. And then up here, 4 and a 20 is 5 times, 3 times 5 is 15. I can then add 15 plus 4, which gives me 19. The denominator stays the same. This is saying that 3/4 plus 1/5 equals 19 over 20. Pay attention to how, again, this is organized. See how the fractions are all on the same line, here and here. That will help you significantly in calculating your work. In this example, I have 4/9 plus 1/4. The least common multiple of 9 and 5 is 45. 9 goes into 45 5 times. 4 times 5 is 20. 5 goes into 45 9 times. 1 times 9 is 9. I can then add the two numerators together, and I get 20 plus 9, and that gives me a final fraction of 29 over 45. In this final example, I have 3/8 plus 3/4. In this one, the least common multiple happens to be 8. So the top fraction doesn't have to change. All I have to do is rewrite it. Below, 4 goes into 8 twice. 3 times 2 is 6. I can then add 3 and 6 together, which is 9. And my final answer is 9/8. In elementary school, you were taught that improper fractions need to be simplified to a mixed number. In middle school, we tell you not to do that. Leave it written as an improper fraction. There are multiple reasons for this. One is that's how you grade it on the EOG. But more importantly than that, when you get into higher level math in Math 8 and in Math 1 and so on in high school, you will always leave your fractions as impropers because they're easier to work with what you'll have to do. So, your assignment is to create a Google Sheet and answer these questions. I've created another video that's listed in Google Classroom that explains to you how to model these fractions and show your work. So in the question, in the assignment, you're going to copy these 6 questions down, and you're going to model the answers that you get on Google Sheet and then upload one of those into Google Classroom. And again, there's another video listed in today's assignment that's been posted that explains how to do that using a Google Sheet. Once the Google Sheet is then completed, you will then save that file, attach it, and upload it in Google Classroom. This will be one of your first grades for the quarter. I am looking to make sure that you do it correctly. Any question that you answer wrong, you will have an opportunity to redo and submit to get it correct. It does not matter how many times you have to redo an assignment, you can still receive a full grade, or rather full credit. You can get 100 even if you have to redo it 4 times. But the expectation is anytime you make a mistake, you have to fix it in this class. So you will always get an A, but you have to continuously work for that A in order to keep your grade up. Thank you.